When you perform your room setup with SteamVR, you are defining a real play area you can use whilst playing VR games. That real play area will be mapped to a virtual play area within the VR application. The system tracks the headset and the hand controllers within that real play area and maps them to the equivalent virtual area. If you stray too close to the edge of the play area, the chaperone grid is displayed to warn you. The teleportation feature allows you to jump to a new location by remapping your real play area to a different virtual area within the VR application. You can then explore that new virtual area, again limited to the bounds of your real play area. If you have set up your real play area correctly, there will be no obstacles for you to bump into. However, there may be obstacles in the mapped virtual area. What stops you walking through objects in the virtual world? The answer is, by default, nothing. Clearly, the VR application cannot physically restrain the person moving around the real play area. So the solution to this problem is to detect as the person starts to collide with an object in the virtual world and then move the play area away, such that the person only touches rather than walks through such virtual objects. There are two parts to this. Number one, generate a virtual representation of the person's body within the virtual world, a body collider. Number two, react to that body collider colliding with objects in the virtual world. The first part, the body collider game object, can be found under Player, SteamVR Objects, Body Collider. As mentioned in the previous video, the player game object might be better named Play Area, so I'll rename it. It represents the real play area you defined when performing the SteamVR room setup, and its transform defines the location of the middle of that real play area within the virtual world. I'm just going to deactivate the cube. Now, if we run our simple program and move the headset around, we can see the VR camera icon tracking the headset, whereas the player, actually the play area, remains static. If I highlight just the body collider, you can see it doesn't move when I move the headset around. So, let's make the following changes. Enable the capsule collider. Set the center of the capsule collider to all zeros. Enable the body collider script. Lock the body collider in the inspector via the padlock symbol at the top right. Then drag in the VR camera to the head in the body collider script component. Finally, remove the rigid body. If I play again, you can see the capsule collider follows the VR camera. The height of the capsule is changing with the height of the VR camera, such that the VR camera always remains in the top of the collider, and the bottom of the collider, representing our feet, remains on the floor. I'm going to make one more change to our capsule collider. I'm going to reduce the radius to 0.01. The reason for this is that, if I didn't, the body would collide with the hands whenever the hands are near the body, and you don't want the play area moving around just because you've dropped your hands to your sides. Now, let's move on to the play area. Unlock here, play area. The first thing I'm going to do is add a rigid body component. Freeze rotation on all axes and the Y vertical position. uncheck Use Gravity. Set the mass to 10. I played around with various values here. I found this gave an appropriate response. Too small and I bounced off the walls. Too large and the response was too lethargic. Under Follow Head, we then deactivate the head collider. You don't want your head flagging collisions with the body collider, which it would do virtually continuously, as your body collider's position is directly based on your head position. And finally, add My Player Collisions script. This script is a bit messy because it has to deal with various issues. First of all, even though we reduced the radius of the body collider capsule, it is still possible, albeit quite rare, to detect a collision with the hands. Furthermore, there are multiple colliders on each hand, so there may be multiple collisions detected with each hand, none of which we want the play area to react to. So, hand collisions with the body will be rare, but when they occur, we must disable the play area's reaction to body collisions. We do this by counting the total number of current hand collisions, and whenever this is non-zero, we disable play area reactions to body collisions. Conversely, if we are not colliding with anything, then the play area should not be reacting to body collisions. We do this by counting other collisions, and whenever this is zero, we ensure the play area is not moving. When the play area is repositioned, e.g. by teleport, we can miss other collisions, so we set a positioned flag, and zero the other count whenever this is set. Whilst other count is zero, we check the velocity of our rigid body. It should be zero. If it is not, then we force it so. This prevents us being bounced back too far from whatever we have collided with. Whenever we collide with anything, with a collider, the on-collision enter function is called. Similarly, when that collision ceases, the on-collision exit function is called. We use these to adjust the hand and other counts. There are some of the other colliders we never wish to count. The most obvious example is the floor, which we will always be standing on. So if the colliding game object has a child game object called Ignore Player Collision, then we do just that. We don't include it in the other count. We derive a hand colliding boolean based on the hand count. If this changes, we adjust the rigid body constraints. Whilst we are colliding with our hands, we freeze all. Whilst we are not colliding with our hands, we continue to freeze rotation and the y-axis position. This allows the play area to react to the collision along the x and z axes, moving the play area such that the body collider is unable to pass through any collidable object. So, let's reactivate the cube and try this out. You can see the play area is moving because the chaperone grid is moving towards us. Let's try this again in a more populated scene where I try to walk through a chair. Our next video will cover the creation of humanoid characters using the Make Human application and the importation of these characters into Unity. We will also cover how to make these characters blink and how to lip sync them to pre-recorded voice clips.